So the next session is going to be a keynote talk, and I'm certain we'll all be excited to hear it. All right, wonderful. So there are pioneers who advance technology, and then there's pioneers who redefine entire fields. And I would say that Mark is one of those rare innovators that has shaped the way billions of people create and experience images, and is fitting exactly into this category. Mark is a professor emeritus of computer science at Stanford University and a vice president and fellow at Adobe, where he recently led the team and is leading the team that is creating the Indigo computational photography camera application for the iPhone. His career has been nothing short of remarkable. Across 5 decades, Mark has been at the forefront of the next revolution of visual computing, from computer-assisted animation in the 70s to volume rendering to 3D scanning, light field imaging, which was one of these areas that inspired myself, and ultimately computational photography. Time and time again, he has helped to invent and reinvent the future. At Stanford, he inspired students through really legendary introductory courses in computer graphics, digital photography, and the science of art. And at Google, his impact extended from launching Street View and co-designing the library project Book Scanner to HDR+, which is deployed on all of our Pixel smartphones, portrait mode, and Nightside, one of the amazing, almost entirely dark indoor demos that I saw. Mark's contributions have been recognized with many of the highest honors in computing and engineering. He received the ICM SIGGRAPH Computer Graphics Achievement Award for his pioneering contributions to computer graphics. He is an ACM Fellow and a member of the National Academy of Engineering. So what makes Mark's career so extraordinary is his lasting influence that he had across research, education, and devices that are used by billions of people around the world. So please join me in giving a warm welcome to Mark Lavoie.
Great. All right, well, thank you for attending. Here's what I'm going to talk about today. I will talk about the Indigo camera app, but this is not an advertisement. I'll use it as a vehicle to talk about the uses of AI in mobile photography and the uses of Gen AI in mobile photography. And then I'll talk about some special problems like specialization and personalization and agents. But first, I have to do just one slide of nostalgia. So the first ICCP was the one that I organized. And so I'm going to take a picture of everybody so that I can compare it to the original in 2005. So one thing that's interesting about the original is look at the abstract for it. The area is old enough that we understand what the symposium is about, young enough that we can still argue about it, old enough that its practitioners can fill an auditorium, and young enough that they still fit in one. So what, has that actually changed at all? Any of it? I don't know, it sounds pretty relevant still. All right, so why are we developing a camera app at Adobe? First of all, it's a mobile app for consumers, hobbyists, and creators, which then is a little bit different than the work I did at Google. High quality images for users with more patience, and you'll see that in a moment. Provide an alternative to the smartphone look. The look to some extent that I and my team developed at Google, and explore new combinations of capture and editing. From a business point of view, we want to avoid getting locked out by the walled gardens of the phone vendors, meaning the Apple native camera app and Apple Photos, the Google Pixel phone and Google Photos, a link that I helped create, so I'm now competing against myself. All right, so the goals for Project Indigo, as it's called, were first of all, as I said, a JPEG with a more natural look. So standard dynamic range and high dynamic range. A DNG, meaning a raw linear image that uses computational photography with the same look. Pro controls, I'll give lots of examples of that. And a prototyping platform that we use internally at Adobe to prototype a lot of things, and I'll give a bunch of examples of that. It's also integrated with Lightroom Mobile. And so there's a button in the Indigo app that takes you to Lightroom Mobile, and there's a button in Lightroom that takes you back to the Indigo camera app. So we launched it experimentally last June. It was free, no sign-on required. It's still free, no sign-on required, with no marketing at all, except for a blog that I wrote. That said, the results were actually pretty good. We got 3 million downloads of the apps in the first 2 weeks. Broad coverage in the tech press. I think the key was that the natural look that I'll show shortly fell into this kind of retro vinyl records trend and became very popular. It didn't look like a smartphone picture. It looked more like an SLR picture. That was fake. This is not fake, the petapixel and so on. And I want to point out just one of these coverages in the tech press, which is this one by Alison Johnson in The Verge, where she said, "Not for the faint of heart." What did she mean by that? What she meant was that the ratings and our retention signals are polluted by the refusal to run on older phones which are not fast enough, and overheating, which Payman mentioned, especially in warmer climates like we're seeing this week. The reason is that we deliberately decided to make Indigo push what is possible on a mobile phone with continuous capture of raw images during viewfinding, a multi-frame computational photography with more frames than standard, that's the patience part, and very large AI models. So we're running 0.5 gigabyte models on the iPhone. So the app is just an ordinary app. It's got the usual kinds of features. It looks like a camera app. The natural look is a variant on Lightroom's adaptive profile, if you're familiar with that, that has separate high dynamic range and standard dynamic range looks. More SLR-ish, as I said, than the native camera look, which really means less boosting of the shadows, less local contrast enhancement. So here's an example. So these lights are washing this out a little bit, but in a fairly dark forest scene at dusk, this is a picture that our camera app would take. The native camera app took this picture, which is not at all what the scene looked like. And that's an example of it. It looks good on big screens as well as on phones. That was one of our requirements. And we embed the look in DNGs as well as JPEGs. So here's the pipeline in brief. The camera aligns and merges a bunch of frames. So Payman talked about that this morning. And then decides what the look ought to be. That's our adaptive color profile. And embeds it as metadata along with the merged frames in a DNG file, which is Adobe's raw format. It also demosaics that merged image, bakes the look into it, and writes it out as a JPEG. So of course you can edit the DNG to a greater extent than you can edit a JPEG if you've ever tried editing, making large changes in JPEGs in a program like Lightroom. So this is not a high dynamic range projector, although it's a fairly bright projector, so we're losing the highlights here, and you'll have to accept that for the entire talk. But it kind of looks like SLR images. It's got, in particular, lots of darks, and we're letting darks stay dark. One of my favorite painters is Caravaggio, the Tenebroso, the dark look. This is a fairly dramatic example where it's a backlit bagpiper, and we let him stay dark because that's what it looked like to the person taking the picture. But I think it makes a dramatic picture. All right, I want to take a little side trip here. You all know basically what HDR photography is, but the part that's changed is the rendering. And let's talk about that for a minute. So what is dynamic range? This is all stuff you know. The digital camera is the max output over the noise in the dark. The file is just what is the integer values you can put in the file. The display we'll talk about more in a bit, the brightest white over the darkest black. Nothing exciting here. HDR rendering has come over the development of a variety of rendering techniques to be known as, if it's brighter than menu white, it's thought of as high dynamic range. So what I mean by that is if the menu white of your display is thought of as a piece of white paper that's 100% reflective, then anything brighter than that will look to you as if it's luminous. So it's a psychological effect that you calibrate yourself according to something that you think is 100% reflective, and then anything brighter becomes luminous. So this cannot make an HDR rendering, but this can. So that's a photographic print. A large one, actually. It's about 7 feet tall, but it's been mounted on a light box in a museum. So menu white in this case is actually the white gallery walls, and this is brighter than the white gallery walls. And so that light bulb actually looks luminous. So it's brighter than some reference standard, in this case, the gallery walls. So I can't simulate that very well. Let's say that this is menu white. I mean, really, this is menu white. I'll display some Mac Finder windows to prove it to you. Then this, where the Italian sausage is the same intensity as that white, looks 100% reflective. This looks luminous. And all it is it's brighter than the menus. All right, so how much HDR headroom does your display have? So the standard formula is just the brightest white over the standard or the menu white log 2 of that. So as an example, the Apple XDR monitor has a grid of 32 by 18 LEDs that can make certain regions of the screen really bright. Then it's got, and that's 1600 nits, which is a measure of luminance. It's got a very dark black, so the contrast ratio is very high, but we're not talking about that now. And then the liquid crystal display, which is high res, has to compensate for that low res grid of LEDs using some clever algorithms developed by Wolfgang Heydrich a long time ago in the graphics community. So it's really a very sophisticated display, and it's doing all that in hardware. And so using that, the max brightness is 1600 nits. I usually set my Apple XDR monitor to 215 nits, so that's my menu white. And that says that I've got 2.7 stops of HDR headroom. I can, a stop is a factor of 2 in brightness, so I can display something 2.7 times, 2.7 stops over menu white. All right, file formats for HDR imagery. So there are these scene-referred file formats, which are the linear image, typically 16 bits per pixel. They can represent the pixel values, but they don't tell you anything about how bright they are. Then there are the display-referred formats, like AVIF or JPEG XL, that are typically fewer bits, like 10 or 12, sometimes on a log curve, and a file that contains information, maybe another curve, that maps pixel values to brightness. The newest standard, which is now becoming fairly ubiquitous, is the ISO 21496 JPEGs or the iPhone HEECs, which are actually the same standard. It was a collaboration between Adobe and Apple. And Google is in on it too. Google calls it Ultra HDR. And what it is it's an 8-bit base image, which then becomes the standard dynamic range image, and an 8-bit gain map, which when added to it, it's not actually a plus, it's done in log space, becomes the high dynamic range image. And then there's some metadata that gives the brightness. So again, I can't really show it to you on this monitor, but that's the base idea, is that there's this base image and a gain map. Finally, the sharing of HDR images, and I think as we all know, the ecosystem is just not there yet. Some social media does it, some social media tries and doesn't do it very well. Payman mentioned this morning. It's actually better for video. Okay, so the DNGs are computational photography as we did on the Pixel, but we underexpose more than the native camera app, quite a bit of underexposure, and then we align and merge more frames. So we have less blowouts at the top, less clipped highlights in other words, and lower noise at the bottom. And then we do no spatial denoising in our camera app. It's all this temporal denoising by capturing a bunch of frames. And since we capture them before you take the picture, as Payman said this morning, it doesn't affect being able to capture the moment. That said, if I capture a lot more frames and I do so a little bit more slowly, I can do some pretty amazing things. So the room where my grandfather clock stands, I made so dark that I couldn't see my feet. And the iPhone 13 produces a pretty noisy image. But with that same older phone, I could take a slightly longer exposure and take a lot of frames and average them and get a really spectacular image in a room where I could not see my feet. And so noise goes down as the square root of the number of images you capture. That's just basic physics. All right, so the app's got a bunch of pro controls. I won't go through those. They're pretty standard. But the pro controls let you do some amazing things with smartphones. So this is the kind of strobe Doc Edgerton photography done by my colleague Florian Kainz using a little setup in his garage with a strobe and the pro controls that let him set exactly what the exposure and ISO and so on should be, and the focus. Also lets you change the number of frames you want to merge, which isn't a control we're used to seeing on a phone. And the merge method. So align and merge is the method that will try to be robust to motion. So if it can't find a match from one of the other frames in the burst, it'll drop that tile of that frame on the floor or downweight it in some way. If you just select a long exposure mode, there are a lot of, you could do the mean, the max, the blend. Here are some examples. Again, done by Florian. This is, of course, the surf at the ocean. This is just a mean mode. Another one. The phone is on a tripod for these. We're working on a handheld version of this. This is a blend mode where it's a combination of the max and the mean. That's from the south end of the Golden Gate Bridge. This is my favorite. So let's see. This is light painting. Florian took a light and he ran it around these flowers while it was merging a bunch of frames. And in order to get the glowy effect, he fed the flowers fluorescent dye before he did it. No flowers were harmed in the making of this. All right. So there's a bunch of extra lab kind of features. One of them is removing reflections. This is also in Lightroom and Photoshop, so perhaps you've seen it before. So I'll just go through it very quickly. It's an AI trained on synthetic reflections. I'll explain that in a minute. It might fail, but it never hallucinates because it's not a generative model. It's not a diffusion model. So here's a quick example of shooting through the window of a cafe, obviously with permission. So there's been a lot of work, including in this community, on removing window reflections. All of these techniques sometimes work and sometimes fail. What we have found to work the best is an AI trained on the synthetic sums of real photographs. So you take two real photographs, like the winter landscape and the window reflection there, and you add them together. The addition has to be in linear space, not tone mapped, and it has to include physically accurate simulation of glass reflection, including the Fresnel reflection terms. And once you have a realistic synthetic reflection polluted image, then you give it to the AI and you say, all right, what were the two constituent images? And you've got the ground truth right there. So it's very easy to train this. You can train it on millions and millions of combinations like that. And it can get very, very good. So here's one of my favorite examples. I'm taking this picture through the window of a music store in Zurich. You can kind of see my feet and my umbrella there. So you can remove the reflection. And in fact, you can separate it into the two constituent images. One of my favorite uses is taking pictures from an airplane. So that's Crater Lake, cleaned up. That's what was removed. Actually, my absolute favorite use is in the museum, where a lot of art is covered with glass. And so that's Rembrandt, and now without the reflections. And there I am in the Louvre with my jacket over my arm. We also have a multi-frame super resolution. It happens when you pinch zoom a lot or use the telephoto lens. It employs natural handshake. So like the high resolution that we developed at Google 10 years ago, the natural handshake gives you different viewpoints. And because smartphones do not contain an anti-aliasing filter, each of those observations contains aliasing. And if you work through the Fourier theory, you can use those multiple observations to tease apart the aliases and to produce a high resolution image. We use, however, different technology than we used 10 years ago. This is now an AI that's giving alignment and weight. It is super resolution. It is not hallucination at all. We can't go to 100x, as Payman showed this morning. So, but here's an example. This is the iPhone 16, pinch zoom to 10x. This is what the native camera does. They obviously have some AI in there, but here's what we do with the super resolution. It's an AI, but it's not hallucinating at all. So it's a pretty big difference. Here's another 16 Pro Max pinch zoom to 10x, the native camera, and here's ours. Again, we have a different look, so it's darker. It's high dynamic range, although you can't see the moon being super bright with this projector, but it's got a lot more detail. I don't know why Apple doesn't do multi-frame super resolution. This technology's been around for a while. It's not that hard. It does require a little bit more time, uses up a little bit more battery, and that seems to be their highest priority. All right, what's next? So I'm going to show you some stuff that are in development in the lab, but will come out soon, and we talked about it in the blog last year. Exposure bracketing and extreme high dynamic range. So the brightness difference between a full moon and a moonlit landscape is 2 to the 19th power, 500,000 to 1, 19 f-stops. You can't capture that dynamic range with any camera in a single shot, not even an SLR. And so you have to bracket. And a smartphone is, of course, at a disadvantage to begin with, and so we have to bracket a lot. Focus bracketing, meaning moving the lens in between frames and then doing some kind of all-in-focus image. You can do that on a smartphone too, because the lens is controllable, although the aperture is not very big. And so this is an example, again, by Florian. I think this is made from 10 or 20 images. I forget exactly how many for the small flower. And we're working on astrophotography, as we did on the Pixel phone. Photo montage, meaning make everyone smile, and computational video, as Payman mentioned briefly this morning. We're also working on Gen AI restoration of bad photos, using your photo collection to avoid identity shift. So here's a published paper about that. The basic idea is, if you have a noisy photo like the one at left, you can do a restoration here to remove the noise. But if you use a generative model to do that, there's identity shift. That doesn't look like my wife. But I have lots of pictures of my wife, and so I can use them to condition the model and to produce a better result. This was a CVPR paper last year. So here's a blown up example. There's my noisy wife and cleaned up. But there's no identity shift. Still looks like her. Here is Cecilia Zhang's husband. He's misfocused. No identity shift. I think even without knowing him, you can appreciate that that looks still like him. And it's because of the conditioning of the extra reference images. And there are a lot of extra reference images. We can also use Gen AI to infill blown out highlights. And this is pretty straightforward, actually. I'm not going to be showing using your photo collection to avoid identity shift, but the results it's something that should obviously be done. If you haven't bracketed enough, in particular, for a car headlight, you can fix it using GenAI. Look at the highlight up on the left side of the Opera House in Hamburg. You can fix that too. The lampshade, the reflection on the water. And so in this case, I'll fix the cannon and the highlight on the floor and also the view out the window. So it does a great job on the cannon and the highlight on the floor, but that's not my Sonoma County. Shot at Fort Ross. So of course, identity shift is a problem even for non-people. Will GenAI eat photography? Yeah.
So you talk about identity shift in your perspective for the technology you created. If someone prompts something that would cause identity shift to happen, do you then just make the AI fail, or do you let it go on?
So we're not, this version that's coming out coming out soon won't solve that problem.
So does it
of identity
hallucinate
shift.
in that case
But
then?
with Photo Labs, for example, as the startup, it's controllable. But the ethics of that are still, it's wide open. It's to be determined what that will be. You can imagine the content authenticity metadata will say, identity shift preservation was used as part of this pipeline. The standards that are coming out will have ingredients. This was computational photography with this many frames, and then this AI was applied with the addition of this extra technology from Photolab, blah, 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 blah. But exactly what it did as a result of that is still a little bit unclear.
So it sounds like it's not being completely avoided for now. Okay, thank you.
Can I ask, when you show those wonderful HDR pictures and using the diffusion models, where the computation do on your cell phone or it's on the data center?
So all of the GenAI results that I showed you are done in the cloud. The basic computational photography is done on the phone. The dereflection was done on the phone. The super resolution was done on the phone.
Hi, thank you so much for your talk. I'm here. Yeah, so I wanted to ask you about sim-to-real, basically, because we are running out of the good film stock photos to be using, and every new data point that we're coming up with is basically a digital photo. And so regarding identity shift, and also regarding like all of the works that have been doing synthetic data to enrich the diffusion models right now, where do you identify the future needs, if there are any? Or do you think that we can do much like we did with the you guys did with the reflection removal, which was entirely synthetic? Do you think that all future data sets are going to be built this way?
Let me unpack that question. So first of all, I'm not equating the generative stuff, the AI stuff, with digital photography. Digital photography doesn't necessarily, there's always processing, but it isn't necessarily processing that changes the image very much, although there is no such thing as a straight photo. But I think your question is mainly about the AI and those effects. And there is a problem there. So for example, Adobe stock photo, which is where you can buy photographs from, is beginning to get polluted by AI results. And it's getting hard to detect between them. Automatic detectors won't work. Hani Farid, one of the world's experts on digital forensics, very publicly on the front page of the New York Times a few weeks ago, gave up and said, "We're losing the battle. I'm retiring to a farm in Vermont." I don't know where that ends up. But there is this danger of boiling the frog, as you will. I don't know how we solve that problem, except through these retro trends driven by the youth. They solve the problem.
A new data set of DV cameras now.
In the back.
Thank you for the talk. I noticed something during your talk that I thought was kind of interesting, and it's that some of the edits, you showed, and everyone was like, "Oh, it's okay." You did the reflection removal, and everyone was like, "Oh, this makes sense." And then you did some of the remove the small building from in front of your house, and that was okay. And then there were some of the larger changes that I could tell got like some chuckles from the room. And my question to you is, what is the threshold of changes that would be okay? Where in the editing is it like too much editing and it's not like the photo anymore?
Photography had a 200-year run. It's over. I just had to say that. No, it really depends on the use case. If you're doing science, you better be careful doing any manipulation that could change the outcome, meaning the scientific result. If you're sending a picture to your children, as I showed several examples of, anything goes. And between that depends on who you are and what your intent is. And there'll never be a way around that. We can do all the content authenticity we want, but if a really important photograph doesn't happen to have the banner that says this was AI generated, it might still be something that we're willing to put on the front page of the New York Times. We'll just have to be careful about who the source comes from. That said, I do think that there will be a gradual move toward viewers, meaning viewing programs and browsers, that will look for the metadata and will put up a little thing that says, I cannot find metadata that ensures this is an authentic photograph. I think we'll actually see that. And that will handle some of the use cases. I think it's something that we as a society will have to navigate, is the bottom line. You need to stop me when...
Maybe 2 more questions.
I have like many pictures. Suppose that I have many pictures of my wife. Then I can take all these photos and I can use them to, if I'm editing some photo that looks bad, to improve the way that they look. So could you do this actively for things that are not people? Like say you want to remove the telephone poles next to this photo of a church. Could you say, okay, I know this is a famous church. I'm going to first find a bunch of photos of this church from other perspectives and somehow use this to guide the telephone pole removal process and the cars.
Sure. Oh, I have a lot of fun. I bicycle to the top of Hawk Hill, which is above the Golden Gate Bridge, and it's like half foggy, and all the tourists are disappointed. And I'll take a picture, and then I'll just say, remove the fog. And it knows what the Golden Gate Bridge looks like. It knows what the city of San Francisco looks like. It produces this beautiful blue day, and I just show it to them. The older people are like, what? The younger people are like, yeah, AI. So yes, the answer is, of course you can. In this case, I didn't even need to give it additional reference images. It knew what the Golden Gate Bridge in San Francisco looks like.
So can you identify like, okay, this is something that I can find pictures of online, but I don't have enough photos in the model that I trained?
There are going to be so many different solutions in that space. There's a lot of different startups in that space. Most of them will fail, but yeah.
Okay. Thank you.
Okay, so let us thank Mark once more for this wonderful keynote. Thank you.